Problem 5. An artist arranges 1,000 dots evenly around a circle, with each dot being either red or blue. A critic looks at the artwork and counts faults. Each time 2 red dots are adjacent is 1 fault, and each time 2 blue dots are exactly 2 apart, that is, they have exactly 1 dot in between them, is another. What is the smallest number of faults the critic could find?
So it's quite hard to think about 1,000 beads. So when I first started looking at this problem, I just thought about short strings of beads instead. So let's think if we had a string of n red beads, then we're going to get n minus 1 faults. And if we had n blue beads, we're going to get n minus 2 faults. So that doesn't seem a very productive way to go if we want to minimize the number of faults. And I tried various different strings until I came up with this string, which I thought looked promising, because it's a string of 4 with only 1 fault in it. And I also noticed that we could stack these up, so I have another one afterwards, and the only faults that we get are inside those groups of 4. We don't get any faults bridging those groups. This means that we could make our entire circle of beads, 1,000 beads, out of this pattern of 4s, and we're just going to get 1 fault for every 4. So we're going to end up with 250 faults. Now that's the a possible minimum. It's an upper bound on our minimum, but is it the minimum? So that made me wonder how many faults every other string of 4 has. So I did a quick check. Now, if it wasn't for this one, we'd be done already. Because every other string of 4 has at least 1 fault in it. And so the example that we have found, where there is exactly 1 fault for every 4 beads, would be minimal. However, we've got this one here to think about that's got no faults in. So can we use this string of 4 to get a better example? So let's see if we can use this string of 4 here that has no faults in it to create a circle of beads that has fewer faults than we had in our original example. Well, if I take the red, blue, blue, red, it doesn't matter what bead comes next, I'm always going to generate a fault. So if I put a blue bead there, I will get a fault. And if I put a red bead there, I will get a fault. Well, this means if we take our 1,000 beads and we break them into 4s, then either each string of 4 will have at least 1 fault inside that string, as we saw from all the examples, or we might see this string occurring, red, blue, blue, red, but then we know that we automatically generate a new fault whatever we put afterwards. So every single block of 4 in our 1,000 beads has to either have a fault inside it, at least 1 fault inside it, or create a fault when it meets the next set of 4. And in that way we know that the 250 that we found before is in fact minimal. There's no way to beat that.